Okay, this video is about identifying functions. What is a function? Okay, well, the definition of a function is that it is a relation that has exactly one output for every input value. Another word we use for output would be range, and another word we use for input would be domain. Those are some names you're going to learn and use as you keep going on in your math classes. Another way to think about it, if you guys like to go get pop from the vending machines, you walk up to the vending machine and you want a Mountain Dew, you push the Mountain Dew button, you should get a Mountain Dew. Okay, that would represent a function. If something else comes out that is bad, that is not, it's not mapped exactly one output for that button, that means it's not a function if somehow you got something else. Okay, so that's a way to think about it, and there's different ways of looking at functions. We can look at them as a list. So for example, I can say that I have this set of ordered pairs. I have the points, so for this function I have the points 1, 0, 2, 3, and maybe 3, 4. And if I look at these, remember my input value is the x value, generally. I'm inputting a 1, I get out a 0. Okay. I'm inputting a 2, which is a different x value, and I get out a 3. That's fine. And I'm inputting a 3, I get out a 4. All those are fine because there's never a repeat of, like if I did a 1 again, another point, and then had a different output, that would then not be a function. So this is a function because all the different inputs have different outputs. Okay, so let's look and see what it looks like when it doesn't work. I'll do the same example, but then I'm going to add another set to this function. Oops. So we're going to do maybe, I don't know, 2, 4. Now what happens is I have when I have an x of 2, I get 3 or I get 4. Those are two different outputs for the same x value. So now this is not a function anymore. Now be careful, you can have repeating inputs. For example, if I told you I had the point 1, 0, 2, 3, and then I have 1, 0 again. Even though the 1 happened twice, what happens each time x is 1? The y is 0. Therefore, it's the same output, so this is still a function. Okay, so that is kind of looking at it as an ordered pair. And going from that, we're going to next do, the next thing I'm going to do is a mapping. I'll just do one of these. It's very similar to ordered pairs where you have points. But if I have a map where I say that these are my inputs and these are my outputs, and I'm going to just list some numbers, 1, 2, 3, my outputs are 4, 7, 9, 8, and again the input of 1 gives me an output of 4. The input of 2, so when x is 2, or I push the 2 button on the vending machine if you want to think about it, gives me an output of 9. And if I push the 3 button, I get an output of 7. This is a function right now. Now, where it's not a function, if I add a line, I'll change the color so you see what makes it not a function. If the number 1 also has an output that goes to 8, now the purple is not a function. Well, the whole thing's not a function, but you can see why with the purple line. Okay, so that's called a mapping, but it's the same principle. The input has to have one output. The one cannot have two different ones. Now, some of you guys might be wondering, can you have the same output? And that is, yes, you can. For example, if I do the same mapping real quick, let me move this down here so you can see this. And I say that if I push a 1, I get a 4. If I push a 2, or I input a 2, I get a 4. If I input a 3 and I get a 4. Guess what? This is a function. We don't violate the rule that if I use 1, I get two different answers. I always get one answer. And it's the same thing with 2 and 3. So that works too. You can have the same output. It doesn't matter. It's all about making sure it doesn't go to another output, or you don't have a different value for the same number. We can also look at this graphically. So let's look at this graphically real quick. And I'm going to show you with the points first of all. Remember the points. If I say the point 1, 2, 2, 4, and 3, 5. So 1, 2 is about here, 2, 4 is here, and 3, 5 is here. Now you guys would agree, I'll make those different, you guys would agree with me that based on what we talked about up ahead, or up above, this relation between these ordered pairs would be a function, because each of these input values do not have they have different output values, and you don't have a repeat. We don't have like 1, 3 or a 2, 7 or something like that. So graphically, this would be a function as long as it's they're not staggered. So let's see what happens when we don't have a function. Let me add one. Let me add 3, 1. And now this is now not a function. And look what happens graphically. If I go 3, 1, what do you guys notice? When x is 3, there are 2 y values. There's a quick way to determine if a graph is a function or not. If you have a bunch of lines, you can quickly see by drawing a vertical line. This is called the vertical line test. So if you do a vertical line test and it hits 2 points, then the graph is not a function. So you have that you can do. So I'm going to look at that, and then I think that's all we really have to talk about at identifying what a function is. Okay. So let me do a couple of quick graphs. I'll do example 5 here for our examples. So this is B5A. So I'll just do a graph like that. B, draw a circle. C, I'll do a piecewise. Okay. So, part A. Is it a function or not? Well, if you draw vertical lines, you only hit the graph once. That means that every x value I pick, there's only one y value. So this would be a function. For part B, if I pick like x is 1, negative 1, sure enough, there's a value here and a value here. There are 2 values, which cannot happen in a function, so this would not be a function. So now this you have to be careful of with piecewise. Remember that open circles mean that the thing does not exist, the value doesn't exist there, and a closed circle means it does exist. So that means if I draw a vertical line here, it's really only hitting the graph once, right here. There's nothing there. Same thing with this vertical line. It's only hitting it there, not there. Everywhere else it only hits it in one spot. So believe it or not, this is actually a function. Because again, the vertical line test is only hitting the graph here. This is not part of the graph, the open circle. So that gives us ways to figure out if a graph is a function or not. Okay? And I think that is it for identifying. Next video we're going to talk about evaluating.